Okay, I think it's recording now. Hello, everyone. Well, I hope you guys are having a great summer. I'm Matt.
Hi, I'm Regina.
And today we're going to be having our first session of our training session for Advanced React track. And the main purpose of this track is how we can use concepts of JavaScript, TypeScript, and React to help us write cleaner, more efficient, and more maintainable code. So today's first session, we're going to talk about, can you see my screen real quick first?
Yeah.
Nice. So today we're going to talk about some of the changes that we're making with the TeacherLay's dev team, specifically TypeScript, and how we can use these changes to help us write more maintainable code in the future. Because we're trying to change a lot of things this summer, and for sure, we're going to want to go over why exactly we're making these changes and how we're going to adapt to them. So first, Regina is going to talk real quick about our new template repository.
Yeah, so for our, oh, good.
Sorry, I was going to say, and like in every session, all of our material will be inside of our training repository, which will be linked in the description. And you can see everything if you need to take a look at what we have.
Yeah, so for our main changes, we'll have three main changes. So the first one will be yarn. I don't know if you guys have heard of that. If you could scroll down a little. Do you want me to share screen, Matt?
Sure.
Yeah, so one of the main changes that we have, oh, there's a chat. Oh, oops. So one of the main changes we have is yarn. So we briefly mentioned it in the last meeting last time. And what yarn is it's a package manager, right? So does anyone remember what NPM is? What does NPM stand for? Yes, Node Package Manager. So yarn is actually also a package manager, right? Why are we changing to that? Sounds annoying. Why would you do that? NPM is the default package manager for Node, right? But the reason why we're changing to yarn is because there's a lot of benefits. So first of all, it's a lot faster. I don't know if you guys remember, but a lot of times during the training sessions back in spring, I would complain about NPM being slow. And as you can see here, it's kind of makes sense. Like here it's like 28 seconds and it's become 1.2 seconds, right? So it's a lot faster. And also there are some security benefits to yarn. So just overall, there's not really a good reason to stay at NPM other than that it's one less thing to install, right? That's one of the big things. Another one of the big things that we want to do is using TypeScript. So when we do JavaScript, we're just typing things from memory. And like also we have to look at context. We have to like error check ourselves. We have to like manually go online after we yarn start or NPM start and check that everything works properly, right? But that is not very scalable. And also it just takes longer to develop and also develop with other people, right? Because you don't all develop the same code. So TypeScript allows you to statically type. It'll have static typing. So what does that mean? Can anyone like give me some benefits of static versus dynamic typing? So static typing is being able to type in the beginning, right? So maybe in like JavaScript, you would just do var x is equal to 1. And then later you can still do x is equal to some string, right? If you do that in TypeScript, that wouldn't work, right? Because you have typed it to a number, and if you assign it to a string, it's going to get angry. Does anyone want to give me some benefits as to why like typing and static typing is useful? Just take a guess. Otherwise, I will call next.
You won't get confused between like changing variables to a different type accidentally.
Yeah, exactly. So that's one benefit. Another benefit is that, I don't know if you have this on here. Another benefit is that like it's faster to develop, right? Because like now your development loop will be faster because you'll find bugs early, right? And then also like if you are working with older code, then you don't need to like surge through and like find what something is. That's actually an issue what I have at my current internship where I have to like dig through code, right? So that's the second change. So just to reiterate, yarn and TypeScript. The third thing that doesn't really affect us is linting. Does anyone remember what linting is from last time? From our CI/CD talk? Trevor, I know you know what linting is. Please tell me what linting is.
Linting basically defines a set of, I guess, like rules or like guidelines for how you want code to be formatted.
Yeah, exactly. So we'll have stricter linting in this template because it's cleaner, and like just having random counts without logs, or just like it'll like help maintain some better code practices. So those are the three main things. There are a few other things that we have. So let's look here. So we have Webpack, which is something that bundles code. So we have our TypeScript, right? And we have our images. It'll take all of these assets, so these images, this code, and it'll bundle it in an easier to access way. So yeah, that's basically it. You guys probably won't need to work with it. It's just something cool to know. And if you ever have any questions about it, like feel free to just ping me. Another thing that we have is something called Husky. So it's really cool because basically on commit, it'll help you lint the files that you've staged. And that's nice because now you don't have to run yarn lint, which is what I taught you guys last time, right? So npm run lint, you don't need to do that anymore. It'll do it automatically for you. And one last thing that we've had is GitHub Actions. As for the GitHub Actions that we have build. So it'll make sure that your files actually build. And then we have lint. So it'll run lint to make sure that your files are linted properly. And once it's linted properly, then the pull request can actually go through, right? And yeah, that's like the main changes as to what we have for the TypeScript template. And this is what you guys will be working on when you guys work on your learning labs. So I'll pass it back to Matt.
All right. Thank you, Regina, for going over a lot of the changes that we've been making. And now we're going to go a little more in depth on why we're switching from JavaScript to TypeScript and how to use TypeScript in particular. Well, first let's go on to some of the reasons why. Like as what Regina said in the past, JavaScript is kind of weird, you know, even though it is the most used language in the world, it is only ranked number 10 of the most loved languages, according to Stack Overflow survey, while TypeScript is ranked all the way up as number 2. And to see why this is the case, let's try doing a couple of examples to see why TypeScript is better and why JavaScript sometimes kind of sucks. So let's say we have a function here. Can you see my terminal okay? Should it be bigger? Is this good? Nice. Okay, so let's say we want a function that will divide two numbers. A, B. We return A divided by B. Now, if we simply do something like console.log divide two nums, 8 and 4, then let's see what we get if we run our code. We get 2. 8 divided by 4 is 2. And that's because when we try doing 8 divided by 4, numbers have a division operator between them. But something that's kind of dumb that JavaScript doesn't help you with is, what if you tried doing something like divide two nums, except instead of 8 and 4, you do apple divided by banana? Do you think we should be able to do a string divided by a string? Let's see what happens if we try running our code. We get not a number, which is kind of unintended consequences because we expect our function divide two nums to get two numbers A and B, but there's no way to enforce that the parameters of the function that are passed are numbers. And that's one of the weird things that sucks with JavaScript. And later on, we're going to talk about how TypeScript with types can help fix this issue. And let's look at another problem with JavaScript, with a function where you might want to call your pet, for instance. Like, let's say I just got a dog for summer because I'm a cool kid, and let's call my dog Rufus. You know, that's my dog's name. And we want a function that says call pet with We want to console.log, and we want to return, right, come here, then plus the name of our pet. And let's see, if we try doing console.log, call pet, my pet. Let's see what our code should say. We get come here, Rufus. And similar to what Regina said before, sometimes where TypeScript really shines is where you want to refactor your code and change it to something else. Like, let's say, for instance, we don't want to pass in Rufus as our pet anymore. What if we wanted to be more descriptive by passing in like a user object, for instance? Like, what if we wanted to make my pet become an object which has a name, like, you know, it's a fancy dog. It has a first name and a last name. And it has a type, like what type of pet it is, which is a dog. Now that we've changed our pet to be something else other than a string, what happens if we try running our code call pet with my pet? We get come here, object, object. And that's because while we want to refactor our code, JavaScript doesn't have anything built in to tell us, oh, you have refactored your code. This is everything you have to change. And later on, we're going to see how some features in TypeScript can help alleviate these problems. So let's see, what exactly is TypeScript? Well, TypeScript is a language that is built on top of JavaScript that helps fixes some of the things we talked about just right now, with how sometimes JavaScript can be a little wonky with static typing, as Regina said before. And as you can see by this visual here, the way that TypeScript and JavaScript hierarchy works is that all JavaScript is valid TypeScript, but not all TypeScript is valid JavaScript. And these are some things with compiled versus interpreted languages, where with TypeScript, you compile it with something called the TypeScript compiler, as opposed to JavaScript, where only the web browser interprets it and runs scripts. And there are a lot of really great features that TypeScript can give you on top of JavaScript, like as what Regina said before, with it helps making developing time a lot faster. It makes refactoring code a lot easier. It also autofills properties of objects, and it can also help catch errors while you're making code, as opposed to when you're running code. So now let's see, how do we get started with adding TypeScript into our applications, our JavaScript applications? And we can do that with Yarn. So since TypeScript is a open source library, we're going to have to add it ourselves using Yarn Add Typescript. And what Yarn Add Typescript does is that it gives us features of TypeScript as well as something called the TSC. And the TSC is the TypeScript compiler. And when we run Yarn TSC, it'll turn all of our TypeScript files into JavaScript files, which the browser can run, because as you can see here, the browser cannot run TypeScript. But before you have access to the TypeScript compiler, you have to run something called yarn TypeScript TSC -- init. And what this does is that it creates a TypeScript config JSON file. And what this TypeScript config JSON file is that it basically tells us, okay, what do we want our TypeScript to do? And you can customize it however you want. And you can read what all of these things do, but for now, the main one that's important is art directory, where we're changing it to build. What this does is that whenever I run yarn TSC to compile all of our TypeScript code, all of it will get, all the compiled JavaScript files will go into a directory, which I call build. So that is how we would get TypeScript set up inside of our JavaScript TypeScript applications. And now let us see how to actually use some things and actually go through typing, as we said before. So let's look at our code here. Give me a sec. And we have our function divide two nums, which returns a number based off the division between these numbers. And if we simply try putting in our JavaScript code, we get a couple of errors. And let's see what it's saying at telling to us. Parameter A implicitly has any type. And this is TypeScript saying, hey, you haven't told us what A is or what B is, and you haven't told us what the return value of this function is. And now we can simply use our typing with TypeScript by using a colon. And what the colon does is that we basically say, okay, this parameter A, I want it to be a number, as you can see here. And we can do that for the rest of our parameters. And just like how with parameters we did B is a number, we can also say, hey, this function is going to return a number as well. Like so. So let's see what happens if we try console.logging dividing 8 and 4 and see what happens. We see that this works just fine. But if we try doing what we did before with console.logging apple and banana, we see that TypeScript yells at us and tells us that we cannot do this because we cannot input a string into the function divide two numbers. And this is really powerful because we can see that before with regular old JavaScript, it said this was completely fine, even though it shouldn't be. And since TypeScript yells at us, then we can know that for sure, if we're trying to push this code to production, that we will try to minimize the amount of errors we have by catching errors like these through static type checking. And now let's see, if we want to see how it looks like by compiling it, all we can do is simply run yarn tsc. Done. And we can see our compiled code into JavaScript. So that's pretty cool. And so yeah, that is an intro to typing and typing functions. And now we're going to talk about how we can use typing for things other than primitives. Because as you can see with divide two numbers, all of our types are primitives, which are just numbers. And primitive means that it's not like a nested object. It's just like a number or a string or a Boolean, something like that. But what if we wanted to do something else? Like for instance, if we take a look at our JS tests, we wanted to use the function call pet, right? Let's say we wanted to use call pet. And it yells at us saying, parameter pet implicitly has an any type. And if we take a look at what our pet is again, like so, can anyone tell me what type our pet object is when we're trying to pass it in? Exactly. The silence is good because you don't know, because how do you describe this? You're like, it's an object with a name object and a type. It's like, you can't simply say the pet is a string or something. You have to change it to something else. And that's where something called interfaces come in. And what an interface is it's a way for you to describe the shape of an object or the shape of argument parameters, argument or function return values by saying, oh, I want all my pets to be of something of this type. And the way interfaces work is as so. Let's say we want to make an interface pet. And the way that interfaces work is that we describe the shape of what we want pets to be. And let's take a look and see, what does every pet have? Every pet has a name, which has a first name, which is a string. It has a last name, which is also a string. And it also has a type, which is a string. And when we said that TypeScript is a statically typed language, it is also a duck type language. And what we mean by a duck type language is that if it looks like a duck, if it acts like a duck, if it talks like a duck, then it is a duck, which means that if an object that we pass in like let's say you want to pass in a pet object through our interface. It will let us do that if the object we pass in contains a name, first name, last name, and a type. And that's how we check types with interfaces. So let's say we wanted to console.log call pet by pet. And let's see if it yells at us. It doesn't yell at us. And let's try running our code by using node. Come here, object, object. Let us see why that's the case. Oh, because change it to pet dot. And look at this. So in the past, when we want to change come here plus pet, we see if we run dot, it gives us everything that is inside of the function and everything that is inside of the global node application, even though not all of these are within the pet object. It just gives you everything because JavaScript has no way to check types and see what is inside of a pet object. However, inside of TypeScript, if I simply run dot, it only gives me the properties of a pet object, which is really nice because that way we know for sure that our object that we're passing in has these properties. So let's say we want to come here, pet.name.first. And if we want to run our code again, and then, nice, it works properly. And let's say we wanted to console.log call pet with a string this time. And let's see what happens there. It doesn't let us do that because argument of type string is not assignable to parameter of type pet. And this means that when we try doing something here, when we try to call the function call pet, it checks to make sure that the argument we pass in is of the proper type that we want it to be and stops us from doing dumb things like trying to pass in a string when we should be passing a pet instead. So yeah, this was a little look into a couple things that we could do with TypeScript. And now Regina is going to go into how we can do a couple more things with React in TypeScript.
Yeah, let me share screen real quick. So, I mean, types is cool, but we're doing React, right? So like, let's do some React. Honestly, this is the repository that I made the other day with my other peeps. But like, for instance, right? You guys, I think you guys, oh no, this still needs so imagine that you have like a function, right? So this is review. This is something that Matt just taught us, right? So if we do return pasta, how can we type this? Please help. I am noob. I don't know if anyone. Anyways, I guess I will. Oh yay! Thank you. Thank you. Yeah. So you do :string, right? That's how you type it, and it returns something. That was review. And so there are a few things that are really useful for in general. So if you want to have props, right? Remember how we had like something like you pass in something into some app, so you go like, oh, there's props, right? So normally that's what we would do for TypeScript, for JavaScript. But it's really useful if we know the type of it, right? So say like we know that app will take in interface, let's call it app props. So we know that it will take in some title, and we know that it will take in some, I don't know, like more information. I can't, my brain is really full. Yeah. Okay. So now what you can do is you can type the properties into app props. And this is really helpful because before you kind of just had to guess and like look, oh no, and look through the code inside of the component to see what exactly the props were. So now that you have this, you'll be able to, like, if other people are using this component, they don't need to read through all of your code. They only need to just check out what app props you have. And like, hopefully you should make the title and more info, like basically the properties names, like easily readable and understandable so that like people don't have to really dig through your code to find out what it means, right? So that's one really important thing for properties and typing that. Yeah, that's useful. Another thing is enums, right? So what are enums? Enums are actually inside of Java, if you guys have used it. I feel like it's inside C++, I'm not really sure. But enums are just type, right? So like here, if you look here, it says enum direction is up, down, left, right. So you're making it so that there's this object thingy that like has to be up, down, left, or right if it's considered a direction. So that's kind of confusing. An example of that is like inside of this app props. So maybe we have something called like direction and then direction. Right? I'm gonna copy this over because I don't want to type it. And so now in the future, anything that's passed in a direction has to be up, down, left, or right. And I'll just show an example of that. Actually, that's good enough. So that's basically what an enum is. One use case of this is like, for instance, like, remember how like before for like some of you guys did the code along? Like for the code along, we have like single list, single item, view single item, or view like all items, right? So if you make this into an enum with like single item, so like if you do like enum view style, and then you make it to as like, okay, maybe there's like single item or all items. In the future, you can add in other styles, right? So if you add in other styles in the future, we can make it so that like view style is equal to some type of view style. So in doing this, it's really easy to extend in the future, like new styles that we have. And it's also a lot better than just passing in a string of like, okay, maybe like view style is single item. The reason why it's better is because it prevents human error. And just overall, it just makes it more clear what's available. So yeah, I think those are the main two things that we have for React. And for React, it's not on here, but for TypeScript React, in order to like just create, you know, before it was like create React app, and then just some app name. Now, in order to like just use TypeScript, you just do --template TypeScript. There's a short like blog on it. We'll send it out later. That's one of the things. And then in order to just run this, since you guys don't know Yarn either, so this is a good review, all you need to do is yarn start, right? So for Yarn, this is npm. The main thing is that like, you see like how in package.json, we have like scripts, right? And before, in order to run like start, you can do npm start, or you can do npm run start, right? Same with build. But test, you have to do npm run test. But for Yarn, all the scripts, you don't need any other words. So it would just be yarn start, yarn build, yarn test, yarn eject. So one of the reasons that we're using Yarn actually is also because it's easier to use. Because it's a little confusing when to use run and when not to use run. Honestly, if you just run both, it's the same thing. But still, it's a little easier. And also, oh, in order to add a dependency, right? Matt went over this a little bit. Like before, you do npm install and then like, say a dependency called Bulma. But for Yarn, it's just yarn add Bulma. Honestly, it's really small difference. You can probably just look this up. But there are tiny differences with Yarn. And also, in order to install Yarn, it has it in here probably. But you just do npm install Yarn. And that's about it. Yeah, so that's like mostly what we wanted to cover today. Oh yeah, one other thing that is important is that like if you notice the extensions, right? If you look here, it's .tsx instead. So what that means is it's a TypeScript expression. I don't know if you guys remember like these thingies. These thingies. This is called JSX, right? So this is actually, surprise, it's TSX now. So yeah, and if you don't actually have this like JSX, TSX thingy, you don't need the X, but that's not really important. And as promised, I will run this, that you will know that it is actually not much harder to run. So now if I type in yarn start, I don't need to do like that, like, I don't really remember like TSX in order to compile stuff. It will just throw things online. So just give it a sec and it will bop online. One thing is, even though like it's TypeScript, right? So it needs to compile to JavaScript in order to be put online. So remember how like we did like Netlify and stuff like that? We just use build. If we do yarn build, then it'll build into JavaScript actually. And once it builds into JavaScript, then you throw the JavaScript online, even though like during development, it's TypeScript. It's a little confusing. Hopefully that makes sense. It isn't starting up. Okay, what else can I talk about? Oh, one other thing. There's a difference between interface and a type. So you can do interface app prop like that, right? But like say you have a function called favorite food, and just like how Matt had, maybe it's like some food, and then it's type like, I don't know, like, oh, there you go. It's type like food name, and then string, right? I don't know why you would have that, but it's a type, right? One thing you can do is you can make it an interface, but generally if you're typing for a method, like here, you actually want to use a type, not an interface. So you do something like type foods is equal to, and then that thing, right? Rather than, we'll send out a doc as to like when to use types and interfaces. It's honestly, if you don't remember, just do interface. It doesn't really matter that much. Like just for something slightly cool is if you do like typing for functions, you generally want to use types a little more. And for like props, you generally want to use interfaces a little more. It doesn't, like I said, if you don't remember, it doesn't matter, just use interfaces. It's not a big difference. I can go over why that is something slightly cool, but it's just a slight optimization. Wow, Yarn is really failing me because we're saying how good it is, and now it is so slow. Cannot find name keywords. Okay, I'll remove that, and then I will show you guys that it works. Okay, what is it saying now? Okay, it doesn't have app props because I didn't pass any props. That's very true. This is an example of how to just put up TypeScript stuff online. And it should go up online now. Yeah, so that's all. It's the same thing as before. It's just yarn start instead of npm start now. So yeah, that's all we got.
Sounds good. I think we're gonna go into a couple of examples with LiveShare, but we're not gonna record this part, but it's going to be inside of the repository if you want to take a look, see at it. And thanks you guys for watching.